Okay, so this video is just to finish up the notes that we didn't finish in class. So we're on number 6 of Rolle's theorem. So for number 6, our interval is from -1 to 5. I can look at the denominator and tell that he is going to have an asymptote at x equals -4. And make sure you understand I'm not hastily deciding that it's an asymptote, because remember, it could be a whole. Either way, I'm not going to be continuous, but I know the top is going to factor with a 5 and a 1 in the back, and none of that's going to cancel with an x plus 4, and that's what would cause a whole. So it's an asymptote. But if you say it's discontinuous because it's an asymptote at x equals -4 and it actually turns out to be a whole, you could lose points because you're making a statement that's not true. So just take a second and just make sure it's an asymptote or it's a whole. Or if you're not sure, then don't specify. Just say that it's discontinuous at x equals -4. But this is not in our interval, so it's a non-issue. So we are continuous from -1 to 5, and we're differential on the open interval from -1 to 5. So all systems are go. So for Rolle's, the other condition is I need to find f of -1. So that would be 1 plus 4 minus 5 over 3, which is going to give me 0. And then I need to do f of 5 minus 20 minus 5, which is also 0. So I've just proved that f of a equals f of b, which is the third condition for Rolle's theorem. Okay, and because of this, I know that my slope is 0. I don't have to go find it. Okay, so now I'm going to take the derivative, and this is a quotient rule, so this is a low d high. So low d high minus, and I would suggest like pausing the video and just going ahead and doing the derivative yourself and cleaning it up, and then checking it against my work instead of trying to do it while I'm talking through it. Y'all know how to do the derivative, so pause the video and do this, and then check it with the video. So that's low d high minus high d low over low low. See, that's a -4 and a +8. And then I'm going to combine my like terms. And I'm going to set that equal to 0, and that's not a random decision. I'm setting it equal to 0 because that's what the slope is between my two endpoints. And that's what Rolle's says. It says, okay, if your endpoints are the same, then your slope is going to be a 0. So I'm trying to find where a point on the graph also has a tangent line with a slope of 0. When I multiply by the denominator, that goes away. This does not factor. There are no factors of 11 that'll give me an 8. Okay, so we talked about this in class. Just because it doesn't factor, I've got two other methods I can solve it. I can complete the square, or I can do the quadratic formula. This is a lovely complete the square, and there are two things I look for. Number one, I look for nothing in the front, no coefficient on your x squared. I also look to see if this number is nicely halfable, and it is. So this is a lovely complete the square. You could go do the quadratic formula, but you need to not shy away from complete the square. So to complete the square, I get my x's on the same side, and I'm going to add the 11 over, and then I'm going to take the 8 and I'm going to half it, and I'm going to square it. And half of 8 is 4, and squared is 16. And when you square something, it's always positive, so this will always be a plus. But you know by now that what you do to one side, you have to do to the other to balance it out. So this becomes an x plus 4 squared. If you were to factor that, that'd be x plus 4 times x plus 4. And that's why this is called complete the square, because you turn it into a trinomial that's the same thing squared. And then that equals 27. And then I square root both sides. And the x plus 4 comes down. Don't forget your plus or minus because you square rooted both sides. 27 is 9 times 3, so that's 3 root 3. And then I subtract my 4 and put it in the front and the ugly stuff in the back. Now, on most of these problems, when you get two answers, one of them is usually outside your interval. So you need to type these in and get decimals. I got a 1.196 for the plus, and then for the minus, I got a negative 9.196. My interval is from -1 to 5, so he's out. So I can keep the plus 1. So hopefully that jogs your memory about complete the square and also about the quotient rule. Okay, number 7. I mean, this is just a very well-behaved quadratic function, does nothing exciting. So we are continuous on the closed and differentiable on the open. And now f of a, nope, not a, f of -3, that would be 9 minus 6 minus 3, which is 0, and f of 1, which is 1 plus 2 minus 3, which is 0, and we just proved that f of a equals f of b, which again is the third condition for rolls. Now, please make sure you understand that these don't have to equal 0. They just have to be the same. These just happen to be a 0. Okay, so now I'm going to take the derivative, and I'm going to set it equal to 0 because I want the slopes to be the same. And that happens at a -1. Okay. All right, applications. I cannot stress enough how important it is for you to go through every single problem on the homework because these can be a little tricky and you need to get used to what has to be written for these. So this says 2 stationary patrol cars equipped with radar are 5 miles apart on a highway, and they're parked. As a truck passes the first patrol car, its speed is clocked at 55 miles an hour. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles per hour. Proof that the truck must have exceeded the speed limit, that's 55 miles per hour, at some time during the 4 minutes. So the first thing I'm going to find, well, let's back that up. I need to be continuous and differentiable. So, hold on. Yeah. So I need to be continuous and differentiable. And this happened over the course of 4 minutes, and speed, velocity is a fluid thing. It's never discontinuous. Even if it stops, eventually he made it from one patrol car to the other. He couldn't have skipped over any part of the highway. So we have to be continuous, and then we also have to be differentiable. So we're just going to kind of state that. And again, this is MVT, not rolls, because what I'm trying to prove is that he exceeded the speed limit of 55 miles per hour. So let's talk about at the first patrol car, we'll call that time 0. He was going 55 miles per hour. So this is time, and this is miles per hour. So now let's talk about the next point. So at the next patrol car, how much time had passed? 4 minutes. Okay, well, I can't put a 4 there because my speed is in miles per hour. I can't put minutes in the same problem with miles per hour. So I have to have my minutes in terms of hours. Well, 4 minutes out of 60 minutes, that's 1/15 of an hour. So 1/15 of an hour later, he was clocked at 50 miles per hour. So to a non-calculus student, they may say, well, you know, if he was seen at 55 and then he was seen at 50, sure, he was slowing down. But we have to take into consideration how much ground he covered. So what I'm going to do is I'm going to find my AROC, my average rate of change. And let's see what it had to be for the course of these 4 minutes. So the average rate of change is going to be y minus y over x minus x, which is going to be 5 over a negative 1/15. And if you same change flip that, 5 times 15 is 75. So guys, what this says is that his average rate of change over the course of these 4 minutes on this particular road for this 5-mile span was 75 miles an hour. So you have to use calculus to justify that. So what you've just found is the AROC. Well, you have no formula to take the derivative of, but you're going to use the MVT to justify your answer. So by the MVT, just watch, and then you can pause this and write it down. By the MVT, there must exist an instantaneous speed, which is your velocity, during the interval 0 to 1/15, where the speed equals 75 miles per hour. That's what the MVT says. Therefore, the truck must have gone 75 miles per hour at some point, I don't know what that is, during these 4 minutes. Now, before you start writing, hold on. Guys, if I hit 75 miles an hour, and I think this comes up in the homework, so I just kind of want to pop this up here. If he started at 50, he was clocked at the beginning at 50 and ended at 55, and we just proved that at some point he goes 75. Can't we also conclude that he went, I don't know, 70 miles an hour at least twice? Once on the way up to 75 miles an hour and once on the way back down from 75 miles an hour. If I know he started at 50, then he had to hit 70 to get to 75. And then if he was clocked again at 55, then he had to come back down, so he had to cross 70 again. So, and that's the same thing for 60 miles an hour or 57 miles per hour. He had to hit all the speeds in between if he ended at 55 or ended at 50. Let me look. Yeah, he started at 55 and ended at 50. Which means he had to cross all the speeds between 55 all the way up to 75 and all the way back down to 50. So all of those speeds he had to hit at least twice. And he could have hit 75 more than once. And remember, the 75 is an average rate of change. So actually that means that he went much faster than 75 miles an hour because it averaged out to 75 miles an hour. So This is an application of an MVT. Now, please make sure you see that in no way, shape, or form does the problem allude to the fact that you need to use the MVT. So you're going to have to be able to recognize when it's needed and how to use it, how to refer to it, and how to use it to justify your answer. So all things you need to really practice on those application problems on your homework.